Hey, everybody. Welcome back to Adventures in Machine Learning. I'm one of your two hosts, Ben Wilson, joined by my other co-host,
Michael Burke. Hi, everyone.
And today we're going to have a very special guest who's going to be giving us a perspective of what it's like studying and writing about AI and talking about it, ML in general, from a university perspective. And one of the interesting things we were talking about before we started the recording this week was that he's not even studying this stuff as a main topic in his university program. And we were discussing how that's actually a fairly common thing in industry. A lot of people that have been doing it for a while or have gotten into the field and have stuck with it, myself included. I didn't study any of this stuff. I studied nuclear engineering, but a lot of people come from mechanical engineering backgrounds, not just pure math and physics or statistics. And we'll talk a little bit about what the perception is about AI in the university students of today, and then we'll talk about a couple of blog posts that our guest has written and some of the interesting topics that come out of that. So without further ado, if you could introduce yourself, let everybody know who you are.
All right. Hi, I'm Maciej Balawejder, mechanical engineering student. I finished my second year, and right now I'm doing my placement year. So internship for 1 year in industry at ASM Assembly. And I'm actually doing more of a software engineering combined with machine learning. And yeah, in my free time, I'm doing a paper reviews on my YouTube channel, which I recently just created. And I'm also writing a blog post on the Medium. And that's how I got found by you. And yeah, today I'm in Adventures in Machine Learning.
Awesome.
Hey folks, this is Charles Max Wood from Top End Devs. And lately I've been working on actually building out Top End Devs. If you're interested, you can go to topenddevs.com/podcast, and you can actually hear a little bit more about my story, about why I'm doing what I'm doing with Top End Devs, why I changed it from devchat.tv to Top End Devs. But what I really want to get into is that I have decided that I'm going to build the platform that I always wished I had with devchat.tv, and I renamed it to Top End Devs because I want to give you the resources that are going to help you to build the career that you want, right? So whether you want to be an influencer in tech, whether you want to go and just max out your salary and then go live a lifestyle with your family, your friends, or just traveling the world or whatever, I want to give you the resources that are going to help you do that. We're going to have career and leadership resources in there, and we're going to be giving you content on a regular basis to help you level up and max out your career. So go check it out at topenddevs.com. If you sign up before my birthday, that's December 14th. If you sign up before my birthday, you can get 50% off the lifetime of your subscription. Once again, that's topenddevs.com.
So what do you see as the big difference when you went to that internship and you see how people do stuff in practice versus kind of how things are structured in school? Could you talk a little bit about that?
Yeah. I think the biggest difference was that at university, you do most of the stuff on your own. Even if you have a team project, there's 5 people, but still there's no much of working with others. But when you go to actual internship, you need to know the structure that's within the company, and you need to learn the structure that it's there. And you need some sort of mentorship along the way. So yeah, the whole process is just completely different. Also, creating the project is not purely academic. When you create the project, you just need to keep, it needs to just run, right? You just need to run the program. You just need to create some sort of project, and that's it. But when it comes to the company, you also need to put it into the workflow that already exists. Mm-hmm. And some of these projects eventually don't fit to the workflow. So yeah, it's completely different. And yeah, it's a good experience to actually see how it looks like in real life rather than just only seeing it in a academic kind of thing.
Do you think that academics are preparing you for this workflow integration, would you say? Are you getting the skill set you need?
No. I mean, not in my university, I would say. It's just completely different. I don't think, I wasn't prepared to create the project in the way that we created in the company right now. And basically the pace of creating projects is completely different, I would say. Obviously, at university, you mostly do it closely to your deadlines and stuff. When you work in a company, you mostly have it more scheduled. So each week you create something, you have a meeting, you discuss what you already done, and then you move forward. When you're in university, you basically leave everything for the last week, and then you just try to get through it at the end. So yeah, it's just completely different.
Yeah, I know there's a couple of schools that in their doctoral program, postdoc, they try to foster. They've learned from industry what's worked in those teams, and then they're like, okay, we're going to model this around how a startup functions. And one of the most successful ones that has done that is UC Berkeley's, what is now Rise Lab. It used to be Amp Lab. And that incubator, because they force people to work in a collaborative environment and people can ask each other questions and help each other out, it spawned so many foundational open source projects that have created multi-billion-dollar companies over the last 10 years. So the founders of the company that I work for, that's where they got started because they tried to do that model. Do you think that more universities should try to adapt that process of building solutions, whether it be traditional, air quote, hardcore engineering, like wrenches and wires sort of engineering, as well as software engineering? Do you think that would something that would benefit the industry?
Yeah, I think especially curriculum these days is not really adapted to put you in a real life workflow. And yeah, I would put more emphasis on the practical projects, implementing the knowledge you already gain and that kind of stuff. So yeah, it will be so much easier. And especially working within the group. I think in university previously, last year I was doing it. It was mostly, especially when we did it during the COVID, it was you literally sit in the house, do it on your own, and that's it. There was a lack of communication, I would say. So I think, just put more emphasis on working in the groups, working with others, and yeah.
Yeah, it's interesting we bring that up. My team is currently, I guess not currently, but this week was at a conference for data science, and it was one of the first times they were all in the same room together, and it was really, everybody just loved it. They said that they got to know each other more in one day than in the 2 years of working together during COVID. And collaboration is a lot easier in that sense. And I think that's one of the things that COVID has really harmed is in-person communication can lead to a lot more ideas pinging off each other and a lot more innovation and iteration. So that's just one thing to note. And then another thing to note is at that conference, it was so academically focused that they all just left halfway through and went and got bubble tea. So there's an interesting divide between the two. Academics tends to bring the proofs that allow a lot of industry things to work, but industry often has to implement it. So if it's too abstract and impractical, it's never used. So bridging the two is a thing that I find very interesting.
100%. And I also think that's what remote working doesn't actually work, because you lack basically being in a group, being in an actual place with the actual people. And I think a lot of ideas are coming from just this quick chat. And I remember Cal Newport, I think he was talking about it in one of his books, that many professors at MIT and elsewhere, they basically come out few times and just come to someone's room and just start to chat, and they exchange the ideas. And that's how they basically got the broad overview of what's going on. And I think if you work remotely and you're not in a group, you kind of lack it. And yeah, I don't think it works. So yeah.
Ben, what's your experience been working remotely?
I don't like it, to be honest. But yeah.
So I've been a remote worker now for going on 5 years. And if I was new to the industry, if it was my first decade of doing ML or data science or running software, I would absolutely be terrified of doing remote work, because it's not that you don't know things or that the things that you know are not relevant to your work. It's more you haven't seen enough to know what you don't know and when to actually reach out and ask for help versus when to spend some time researching on your own, or how to effectively get yourself unblocked, or, have listened to and engaged in enough conversations with people who have a different perspective on thinking through problems and working on things. So it would have been terrifying for me. Now that I've been doing this for a while, and I can work a lot faster and I don't need to be looking stuff up all the time when I'm doing an implementation or doing my day-to-day stuff. So I can work faster if I don't have distractions, and it's more efficient for me. But at the same time, that's also detracting from junior people who would benefit from that interaction. So I'm remote not because I don't like humans. I'm remote because I'm just geographically removed from my team, like across an entire continent. And in fact, half of our team is on the exact opposite side of the world. So we have to be remote, but we do things like daily stand-ups and like ad hoc interactions. We talk to each other many times a day. In order to get that interaction, we require video to be turned on so we can see each other and kind of, put a face to the voice. And it works pretty well, but it's definitely different when you're physically in the same room as people, and you can do that, lean across the desk and kind of be like, hey man, can you take a look at this? Like, I can't figure out why this is throwing an exception. And then they'll just be like, oh, check that. Okay, sweet. Cool. So
yeah, for context, Ben works on some very state-of-the-art cutting-edge problems. I would find it daunting and almost like impossible to work in that environment without any external help. But Ben, you're saying that you overall think you have the technical capabilities to do these giant projects by yourself, or do you still rely a lot on external collaboration and input?
Oh, not a single thing, unless we're talking about a bug fix or we're talking about, very simple bit of code that you're writing. That doesn't require anybody's input. It requires them to look at what you've done and approve it. And no matter how senior you are, you need that because we're human. We make mistakes. But for any significant project, a serious company is going to have multiple rounds of design review. A lot of documents are written. A lot of meetings are had. And you open it up for all voices to be heard and to basically absorb all comments and opinions that people have. And that helps to inform and expose what you weren't thinking about. And no matter how many years or decades you've been doing a job, I look forward to the comments from people that are like recently out of school. They might be thinking about something in a way that just based on generational gaps, I'm not thinking of in that way. Or it's just some new way of thinking that was instructed or that they used while going through school, that they can analyze things in a way differently than I do. So I love that feedback. And yeah, I won't work on anything where I've got more than a couple of days of effort that needs to go into it without getting people to at least look at what I'm planning on doing.
Yeah, that's what I was basically referring to, like basically guidance. So much easier when you got people around and they also know what they're doing, so they also can guide you. So yeah.
And not all companies are like that, by the way. You got lucky with your internship. There are some companies out there that adopt the sink or swim methodology, and it's almost like they set up people for failure or just dump a bunch of stress on their shoulders. I've seen it with software engineering groups. I've seen it with analytics and data and AI groups where the new person to the team, they just get, after they do their onboarding, they get a list of tasks like, hey, here's your quarterly goals. Go figure it out. And they're like, well, where's the data? Like, what systems do I need to? And then the supervisor or mentor was like, it's fine. You'll figure it out. We all go through this. It's like you're setting this person up to they'll either suffer through this pain and get good, but they're going to be sort of turned off to the company because it's a really bad experience to have to go through that stressful path, or they're just going to quit and find a job at a company that doesn't treat them like garbage. So you got lucky with that internship since you're getting mentorship and stuff. That's good.
Yeah. Coming out of school, what types of things do you look for in ML or AI jobs?
Yeah, that's a good question. I'm probably going to do masters, to be honest, with AI because I like research. I like the research papers. I like to read them, implement them. And currently, when I was thinking, because to work during my third year, I also want to work part-time. So I would probably do some computer vision because I got pretty good background in it. So yeah, I would probably look for computer vision jobs and yeah, we'll see how it's going to go.
Well, what aspects about the role or the company do you look for? Like work-life balance, high pay, big name.
Currently part-time, so it's like flexible enough to actually do it while I'm doing university, my third year. So that would be great. But yeah, to be honest, as I said, I'm looking for a mentorships also. I want to gain experience and also meet inspiring people, and yeah, just have a good team, also work on some interesting stuff. I saw lately Sterling Bank offer. They have a pretty good job. But yeah, that's what I was thinking of. That's my main thing: flexibility in terms of a job and just gain experience. That's, I think, the most important.
Is there any sort of overwhelming desire that any of your classmates have, or people that are also on internships right now? Do you keep in contact with them and they say like, "Oh, I'm working on this really cool project," and then maybe another person's like, "I'm updating tables in the data warehouse"? Do you have like this wide range of responses from your peers of things that they may be doing data science work, but it's a wide variety of work?
To be honest, most of the peers from my university, they didn't go on an internship because it's not obligatory. You can do it, but you don't have to. So yeah, most of my friends didn't go, but most of the response I've got in the company that I'm working, they pretty happy with it. And yeah, they didn't have any complaints about just not doing anything.
Interesting. And the tasks that you're given right now, how broad are they? Is it highly specific, like, hey, just do this one little project and then we'll move on to the next one? Or is it a wide range of things?
To be honest, it's wide range because I don't have a background in software engineering, but I had to learn Java. I had to learn C# because I was doing Windows app. I was doing data analytics in Power BI. I was also deploying some small machine learning models. So obviously PyTorch. Yeah, there was like a broad range of, as I said, mix of software engineering and machine learning stuff mixed together.
So deploying PyTorch models and writing Java and C#, that sounds more like an ML engineer role versus the other side of the house in this, like in our field, which is more on the pure data science side. Which one of those paths, if you're going to go down and go through a master's program and then look for a job later on, would you go more on the statistics and sort of scripting implementation side of data science work with just building models and trying to solve problems, or the more engineering side of what you're doing right now?
Definitely I would go for implementing models. And also there's the engineering part of machine learning, deep learning. So train them and deploying. So yeah, to be honest, my end goal would be researching, but we will see how it goes. It's obviously a lot of companies require PhD in it. So we'll see how it goes with the masters and what's the options going to be after masters. And yeah, if I can find a job in the researching, and I think DeepMind has really good offers about it's not only research, but also engineer and you implementing models. But obviously later on you can go to the researching and going further with it. So yeah, we'll see how it all plays out.
Yeah, they have a very interesting infrastructure there in that team and some extremely brilliant people that I've had the pleasure to talk to before. I think you would enjoy it if that's where your path goes. It's a really cool group.
For sure, yeah.
So kicking on over to the other part of why we're talking today, which is this YouTube channel that you created and your Medium blog post that you're writing. Tell us a little bit about why you're doing that and what it is that you're mostly talking about so that people can have an idea.
Okay, so to start with, I began writing on Medium around a year ago. So it was purely, I think everyone has that idea at some point that you read something and like, oh, I can do it better. Or I can add something to it, isn't it? So I was reading one of the blog posts and I didn't see a clear explanation on what of the problem was Q-learning. So I thought maybe I can write it and just add some information on the top of it. So that's how I started. And yeah, my Medium blog is mostly right now about deep learning and like clear explanation of really with using basic visualization and really plain English. to explain some of the topics that might be hard, like loss functions, optimizers, normalization. So basically the basics of deep learning. And to actually solidify my knowledge and expand it in deep learning, I also started a YouTube channel where I do basically a paper walkthrough. So I analyze the paper, I just cover the key ideas, main concepts of the paper, and explain how it basically works. And yeah, I also implement these models in PyTorch and I share them on my GitHub. So,
I mean, you didn't just do that. You have a couple of walkthroughs on how to implement neural networks from scratch with NumPy, which that's a fun exercise. I don't know any listeners out there who are involved heavily in deep learning and you really want to understand what's going on, like computationally behind the scenes. I think that's an excellent exercise. And I did check out your post on that. I was like, yeah, this is really well done. This is pretty cool. And it really breaks it down in a way that somebody who maybe doesn't use, you just use the high level APIs around like PyTorch or TensorFlow, and you've seen a couple of images and animated GIFs of this is how convolution works and this is how it's stepping through and like effectively rastering an image in order to create these vectors, but hand coding that in a vector array language or framework like NumPy is pretty darn cool. So definitely check it out. It's worth your time.
Yeah, and actually it came from, I did some of the courses, probably, Coursera, NG. I did some Udemy, and at some point I was just asking myself, do you really understand what's going on there? Do you really understand how neural network works? Like how a sequence model works? And I was like, yeah, I don't know, actually. I actually don't know. I need to code it from scratch, get to that low level and build on it and actually understand it so I can use it. So that was my main idea. And that's what I actually right now I'm doing. So all of the other posts about loss functions and normalization and all that stuff is just to basically really deeply understand what's going on in deep learning and machine learning. And most of this stuff that I'm doing out there is built from scratch. So like from first principle, like from the basics blocks to really understand it. And yeah, that's what I'm doing on Medium.
Hi, this is Charles Max Wood from Top End Devs. And lately I've been coaching some people on starting some podcasts and in some cases just taking their career to the next level. Whether you're beginner going to intermediate going to advanced, whether you're trying to get noticed in the community or go freelance, I've been helping these folks figure out how to get in front of people, how to build relationships, and how to build their careers and max out and just go to the next level. So if you're interested in talking to me and having me help you go to the next level, go to topenddevs.com/coaching. I will give you a 1-hour free session where we can figure out what you're trying to do, where you're trying to go, and figure out what the next steps are. And then from there, we can figure out how to get you to the place you want to go. So once again, that's topenddevs.com/coaching.
And the one that we initially, read and found with the optimizers, basically like what loss function should you be choosing for a particular different use case, fits in pretty well to a topic we were talking about. I don't know how many more episodes ago, Michael, where we're saying like, well, what should we use for basically a validation score for a particular type of model. And I really liked how you presented that with showing like, hey, here's how this thing would fit, and this is how it's optimizing this, linear equation to fit these data points. Here's one without outliers. This is why this particular metric is pretty safe for that. And then here's one with, extreme outlier, and here's actually how it's going to fit if it's optimized to this metric. And those core fundamentals, a lot of people assume that most data scientists coming into a role like just know all that stuff, but it's not something I've seen that's very common until people need to learn it. For practitioners, people are usually like, we just always use RMSE and that's what we optimize to. It's like, well, your business is complaining about this outlier that the model is not able to capture. You're optimizing your model to basically ignore that. And this is why you have this issue. So what if you change to a slightly different more, it's like maybe it might seem like an esoteric algorithm, but you talked about one with the Pareto error metric, where it's robust to outliers, but also the way in which it calculates its actual metric makes it so that your model, if it's optimizing to that metric for iterations, you might get away from problems of fit where it's overfitting on things that you don't want it to do. So I think people understanding how all of that stuff works and why these equations were built in the first place. And if you look back far enough, some of these equations, if you look at the original research paper, I always like have people that I'm mentoring. I love the mind-blowing thing that I can do where I'm like, hey, like all this stuff about deep learning, and people are like, yeah, like TensorFlow, PyTorch, these are all, yeah, it's cutting edge. I'm like, yeah, but the like original papers that were written about that? They're like, well, no, the packages were just released a couple of, years ago. I'm like, maybe 14, 15 years ago. I'm like, no. Like, look for the things that those papers are referencing, like the original ideas. And then people's minds just get blown when they're realizing, hang on, this was thought up before computers were a thing. And people were doing this on paper with pencils and theorizing about how this would work. I'm like, yep. And a lot of the other algorithms that are out there, linear regression, that process, that's not even 20th century stuff. And that's hundreds of years before that. So it's always fun to see that. It made, like, when reading through a couple of your posts and about how they are written from that first principles perspective, I just kind of like sort of smiled to myself. I was like, yeah, this guy's going back to original sort of research about it. Like, hey, here's the equation, but I'm going to explain the equation and demonstrate with plots and an example that makes it very understandable.
Yeah, I think if you don't ask why when you do something, you are likely to fail. When something doesn't work in your code, you're just like, I don't know what's going on because I don't understand how it works, right? So if you ask yourself why and you build it layer by layer, your understanding of the subject, you basically, if something fails, you can actually identify the problem and solve it. So I think in order to really be in a field, I need to understand how it works, right? To build a model, I need to understand how it works. And that's
being devil's advocate a bit. There's, let's say you're building whatever model you're building. There are no doubt 10 to 20 tutorials that will do something similar online. Why do you need to understand deeply what's going on when you're just optimizing accuracy?
Yeah, mostly when it fails. You then don't know why it's failing.
So it helps you debug.
You understand,
what else?
I guess mainly you just feel, I think if you do something blindly, it's kind of loses also its point. I don't actually have a pleasure, for example, when I write some of the code or like do some project. If I copy it from, let's say, already built repo, it's not the same even pleasure when you do it on your own and you actually understand it. And obviously it's also, you can't share your work when you don't understand something. Like, how can you write an article about loss functions when you don't understand how they work? Like, it doesn't make sense, isn't it?
I mean, there's hundreds of them that have been published.
Yeah, but they help me. But they help me to understand, isn't it?
Yeah, to get one that you can read, and you're like, okay, I'm not familiar with this topic, but after reading these 7 pages, I know where to go next, or what the next topics to understand are, and that's the benefit of a well-written series of blog posts, which both of you do. And
just one thing I want to mention. Basically, if you learn how to learn things, it's going to be easier with whatever you're going to do. So it's not only on machine learning or whatever topic you do. If you learn how to learn, you can learn whatever you want, right? And if you learn how to break down problems to basic principles, it's going to be so much easier later on in life, isn't it?
Definitely. Could not have said it better.
Yeah, I remember in the ML Flow podcast, just something that really stuck with me was someone said that the key to learning things quickly is having the fundamentals down, because the fundamentals transfer to a lot of different types of problems. So if you really understand what's going on the back end of simple things, then you can use those as building blocks for more complex things. So I completely agree.
There's a really good blog post from Andrej Karpathy, and he actually wrote that in order to actually work on the deep learning projects, you need to understand how to build the backprop first. That was his main idea. So his idea was basically you need to break down everything to simple pieces. and built on it in order to really understand. And yeah, I'm totally agree with it. But yeah.
And what are some advantages of understanding things deeply that you've seen?
Ooh. I mean, if you understand how, like in a context of specificity with ML, if you understand how something like the internals of, a lot of people use stuff like tools for supervised learning. Everybody's using stuff like XGBoost, LightGBM, and these high-level packages that make the process of building something simpler because they're abstracting away the complexity of the internals, which I'm a big proponent of. I think that's very important. But there's a lot of, if you look at the API docs for any of these packages and just look at the fit method for XGBoost, for instance, read through the API docs and see if you can understand, without looking at the description, just the name of the argument, what everything does. And if you don't know what that stuff does, even after you go back and read the description in the docs, and if you're still like, I have no idea what this does, how are you going to tune it? How are you going to change those values in the places and times where you should change them? And also knowing that a lot of those knobs that are exposed there, yeah, they have defaults, but they're defaults because you need a value to be there in place. They're not going to put a none. They put that default in visibility of the user to sort of let the user know this is what the placeholder is. Some of them are things that you can just leave alone, particularly when you're just rapidly iterating. But there's other things about, I can't even tell you how many times I've talked to teams that they're like, yeah, our model accuracy is super great. Like, okay, what's the distribution of the split between for your binary classification task that you're doing? And they're like, oh yeah, it's like 50-50. I'm like, cool, awesome. And what's your accuracy measurement? And they're like, oh, it's, on holdout data, it's 99.998%. Like, do you think that's good? They're like, yeah, it's great. It's like such a perfect model. And then you come to find out when looking through their code that validation data set, the split that they did was actually post-training. So the model actually already saw that data, and it's now just validating on something that it already trained on. And you're like, okay, now let's take prod data and let's run it through the same feature engineering pipeline that you did for this model. Let's validate it there. And you're like, okay, it's 0.05 accurate. It's garbage. It learned like the complete wrong things. It just overfit. And then they're like, well, what went wrong? Like, let's look at the actual decision logic that's coming from this model. Let's print out this tree. And you look at it and you're scrolling for hundreds and hundreds of pages through font size 8 of if-else statements. It's like, well, when you modified this particular argument to say, yeah, I only want 100 trees, but I want max tree depth to be 800. That's A, why it was taking forever to fit. But B, that's why there's only one element in each leaf of this. So it's going down through this decision matrix and saying, okay, if it meets this exact criteria, this is the value. So understanding like how those algorithms work from a general concept is incredibly important, but also understanding a little bit about the implementation details about what this argument or this parameter actually does in the execution of training. And I'm sure, based on some of your blog posts that I'm looking at, you do a lot of computer vision stuff and a lot of stuff with like PyTorch. And what would you say is important about understanding those APIs of frameworks?
Yeah, I used them before I wrote any of this post. And yeah, it was just, if I had I couldn't create stuff on my own, actually, because I always use someone done some implementation, I was copy it, or, I add one more convolution, but I don't know why there's a batch normalization, and I don't know what batch normalization does. Maybe I'm going to put it after fully connected layer, and essentially you don't know how to move around this stuff and you don't know how they work. And when you actually understand how they work and why they are put there, because everything you got in machine learning and everywhere is just put for a reason, right? So if you understand this reason, you can actually manipulate it later on. You can actually, maybe this fully connected layer shouldn't be here. I'm going to put something else. Or maybe if I get this out, so it allows you to do much more stuff when you understand them. Basically, space of action is expanded. But also, I think understanding stuff builds your craft in the field. You become really good at something, and it's naturally rewarding if you become better and better. You just feel good.
Yeah, definitely. That brings up a great point that you said about changing model architecture for deep learning when you start haphazardly just trying stuff out, which we've all been there when we started playing around with these libraries. Like I did it too. I'm like, okay, I'm going to take ResNet model. Let's see what this, architecture looks like. And just like, wonder what happens if I add something here, like change the optimizer here. I'm going to create a pooling layer here. And you sort of brute force explore the API. At least that's what I do that with most packages. Even today, I do that. If it's not something that's, work related and I'm just trying to learn something, I'll play around with the examples and the demos, try to get familiar with like, oh, this is when execution happens. This is how I can access things from this. But when it's something that I would be applying to a work related task, or like, hey, I need to interface with this API and create a wrapper for it, I have to go into the source code and dig through, like, how does this implementation actually work? And why is this part of it so slow? Or why is this so, why is there a conflict here? If I set this parameter, why does it throw an exception here? And I have to look through it and understand it. But there's another aspect of ML that some data scientists are not wholly ignorant of, but it's not a priority for them. And then there's other data science and pretty much every ML engineer out there, at the top forefront of their worry is production stability and cost. And production stability, you can't attain that if you don't know what's going on. With that example that you gave about like, hey, should I change this layer? Should I move these around? If you don't know what those layers do and why they're there and how to manipulate them, when production has an issue or your deployed model starts drifting like crazy and it predicts nonsense, it's going to be a very painful experience, like trying to troubleshoot what's going on and like, where do you start? And then that cost part of it is, if you don't know which of those settings or how your implementation is going to affect the runtime and the amount of computing resources that you need, you might not care about it. Like a data science practitioner might not care, and a lot of them don't. But I guarantee you, somebody at your company is going to care a whole lot. They're like, hey, why did we spin up 64 TPUs on Google Cloud that ran for 3 weeks straight? That's coming out of your budget, right? People get really upset about that. And it could be that, hey, you wrote a for loop where you should have, distributed something, or some part of the code was locked as single threaded and it should have been asynchronous. Without that knowledge and without that discipline to figure out how stuff works, solving either of those problems is very challenging.
And I think it goes also to if you want to do research, you got to understand this stuff, right? So that's what I'm basically breaking it down also to understand. And later on, whatever you're going to do, you need this understanding. That's my idea. I know some of the people don't do it. They just use API and use ResNet 50 pre-trained. True. Let's go for it. But I just rather do it this way, in a more meaningful way and more, just more understanding, rather than just blindly following, something that's already been done.
Yeah. And one more point on that. One of the things that I have really benefited from going really deep into simple mathematical concepts. So like, if you really understand RMSE, you start developing intuition about how it works. Like, you laid out some really good frameworks, sort of like axes for when you're choosing which loss metric you want to use. Well, all right, sensitivity to outliers, interpretability, speed of calculation. And you can sort of think of these as expanding features in a feature space for selecting whatever metric you want to use. But that's very analytical. And sometimes you just sort of want an intuitive understanding of, well, if I increase this feature by a little bit, will RMSE be sensitive? Like that, just having sort of intuition about how those fundamental components work really helps you develop solutions a lot faster. And it also, as Ben was saying, it helps them generalize. You have a lot more faith in the stability of those metrics if you really know what's going on. So it's also kind of fun. Like, some people don't like getting into the weeds, but sometimes I personally love going in and like even writing stuff out by hand, because you're like, oh, that if I do this, then this happens. If I do that, then that happens. So just a plug for learning deeply.
We are machines after all that's going to find patterns everywhere, right?
Mm-hmm.
So it's really cool to develop this kind of high level, low level understanding of the subjects. And as you said before, Michael, it's just transferable to other domains, right? If you learn how to learn, you can do it. You can do whatever you want. So,
Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
I mean, I've always been a proponent, and I've always said for many decades now, the purpose of university is not to teach information. It's, if you think about any domain that you're studying, even if you're doing postdoc research, that's going to be highly narrowly focused on one very small subdomain of a much broader ecosystem of knowledge. But undergrad into a graduate program, you're becoming more finely tuned, not so much in just knowing a lot of things about a topic, but it's the process of the rigor that you need to achieve in order to understand something at that level of information and fully understand everything about it, of that subdomain. And that's what's most critical in a technical field in industry. We have very short, not so much short monetary budgets or small monetary budgets in industry. We have short time budgets. And there's always thousands of competing ideas for ways to spend your time and ways to spend your energy and your human resource capital. In a data science team or where I work now in a software engineering team, our backlog is thousands of elements big. I mean, we have a backlog that I've never seen in any other company. And that you go through it and you're like, wow, like 90% of these are all really good ideas. Like these are things that people would really enjoy and would really work on. We're never going to get them. Like it's never going to happen. So being able to, because you're human resource constrained in these jobs, you have a limited time budget to get things out. And if you're fumbling around and not really understanding how pieces fit into, to one another, or how to analyze super complex things in a way that you can distill it down to those base parts and saying, okay, I know how service A interacts with feature B. And that means when I create feature C, I know how to interface with these things. That's sort of the golden thing that you get from university, I think. And I wouldn't say it's something that everybody sees in that way. A lot of people are like, hey, diploma is a ticket to a salary, and it allows me to go on and do something with my life that I'm going to get paid a lot of money and I'm going to work on, do these cool things. So I think it's refreshing to hear from somebody who's in school right now, who's got that mentality, because the mentality you're talking about is what makes world-class software developers, world-class data scientists, ML engineers. It will serve you well in your career.
Yeah, thank you. I think one thing to add is what you describe is basically rat race. So everyone just wants to, have a goal and just basically want to achieve it as soon as possible. And the university for many people in diploma is that kind of goal, right? Mm-hmm. But a lot of people are saying you shouldn't focus on the goal, rather on the journey. So the only way to focus on the journey is actually develop skills on the way. Yeah. And don't actually look only at the goal, but also what you're doing, how you meaningfully can gain it from the time that you're at university, at your work, at what you do in your free time. And understanding stuff is one of the best way to do it, right?
Mm-hmm.
Which is the best way to do it.
Definitely. This has been like an inspirational talk episode. This is great. We don't usually do this. This is awesome.
Lately I've been reading a lot of Cal Newport. So I don't know if you know him. He wrote a book about deep work and that kind of stuff. How to live more deep life, let's say. So yeah.
It's words of wisdom.
Yeah. I mean, essentially, whatever skills you learn, if you do it meaningfully, then it serves you on many different platforms. And then, as I said before, we just develop skills that are transferable. And whatever you're going to do, I think the simple example is if you learn programming language and you understand how it works in general, and not only the syntax, basically you can easily go to other programming language and start to code it, right? But if you learn only the syntax, if you go to the other programming language, it's going to be really tough, isn't it? So yeah, if you understand the underlying patterns of whatever you do,
couldn't agree more.
Stuff's going to come easier.
Yeah, and for any listeners that are out there that are thinking about like, hey, what is this whole like ML engineer role in industry, and what are some skill sets that you need? That's one of them. The number of languages that you might have to touch as an ML engineer in industry, you could be writing stuff in probably a lot of Python, depending on your company, a lot of Java, could be some Scala, definitely SQL, probably many different forms of SQL. And you're probably going to also need to know how to be an expert level scripter, specifically Linux command line scripting and potentially PowerShell scripting. And you might need to learn some .NET languages. You will probably be exposed to C++ at some time. And being able to understand the fundamentals in each of those languages and what they can and can't do and what they're optimized for and what they're not optimized for will allow you to make the right decision of what to choose for an implementation. Like you more than likely aren't going to be writing ML implementation in base.NET C#. You'd have to write the library from scratch, waste of time, just use Python for doing your training, for serving. Depending on what your infrastructure needs are, you're probably not going to use base Python for that. You're going to be, doing some sort of vectorized operation on numeric vectors. So it's going to be Python, and you're going to compile that and make it so that there's almost no processor latency while processing that row of data effectively. So I couldn't agree more with those transferable skills of understanding how this thing works so that you can know like, oh, that's how memory allocation works in Python versus the JVM is completely different and hash tables are different than heap, garbage collection management. That will really serve anybody who's in this field to grok that. All right. Any closing thoughts? Anything that the two of you would like to just bring up? This has been fun. We're kind of running on time, but any final parting words?
I would say enough words of wisdom for today. So no.
All right. So
I'll second that.
So in in this episode's description, we'll have links to your YouTube channel, definitely to your Medium blog posts that have been done. And what I really hope for is a year from now, you'll be back on talking about the next thing that you've learned, your next internship, and how you've applied some of these things to your journey in learning this. So best of luck in the next many months of your life and your journey in learning all of this stuff and helping others learn.
Yeah, thank you. It was a great talk. Thank you for inviting me. And
all right.
Have a good day.
All right. So until next time, we'll see you. I've been Ben Wilson and
Michael Burke.
And thanks, everybody.
Bye, everyone.
Cheers.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.